Good afternoon, students. So today we are going to discuss the most important topic, which is nothing but negative energy states and antiparticle. So we are going to discuss the negative energy solution, negative energy states and its explanation, and corresponding antimatter. So before going into the class, in the last class there was a mistake in the slide that we are going to rectify today. And we know that this is your Dirac spinors. So yesterday in the last class we discussed about the wave functions. The wave function is nothing but your 4 column vector. So 4 vector in a column. So this is the first one, second one, and third one, and fourth one. Okay. So this is for both for E plus, one is for spin up and spin down, and these two for E minus, negative energy states, and one is for spin up and another one is for spin down. So those 4 vectors in a column vector are nothing but Dirac spinors. And of course we know about Pauli's spinors, which is nothing but sigma x, sigma y, sigma z. So we know, so Pauli's spinors. So this is Dirac spinors. Okay, Pauli's spinors will be always 2 by 2 matrix. Dirac spinors will be 4 by 4. So this is 4 components in a column vector. Okay, so we will have to have the difference. Now negative energy states, very important thing is the wave functions, whether they are complete or not. Of course normalization constant will work out. So complete condition should be satisfied. For any wave function in quantum mechanics, the completeness condition should be satisfied. So for that we need to have this condition. So we have a ket vector and bra vector. So we have a ket vector and bra vectors. Okay, and we have a tensor product. So there was an error in the last session. So now we are going to have the correct one, correct slide, and this must be your tensor product. So when you are going to multiply with the tensor product, that is matrix multiplication, you will get this answer. And the second one will be, you will get this answer. Okay, and the third one, 0 multiplied by 0, then 0 multiplied by 0, this 0 multiplied by 1, this 0 multiplied by 0. Similarly, we will go with all the 4. Similarly, we will go with all the one, next one. So you will have the third matrix, and this will be your fourth matrix. When you are going to add all the 4 matrix, you will get as identity matrix. As I said earlier, for any completeness condition, we need to have the answer as vectors, operators. So we have an operator, identity operator. This identity operator is nothing but equals 1. Okay, so this is the completeness condition. So it has to satisfy. For any quantum mechanics, the wave function should have 2 conditions. One is normalization and the another one is completeness condition. So completeness condition is satisfied for Dirac spinors. Okay, that's the main conclusion. Now today we are going to see in detail about the negative energy states, and of course we know the solution of Klein-Gordon equation as well the solution of Dirac relativistic equation. We know this one. So in Dirac relativistic equation also we obtained the energy value. This energy value is nothing but plus or minus. It's given as plus or minus. So one refers positive energy states and the another refers negative energy states. Positive energy states we know already. So energies are positive. So we can grasp the ideas. Whereas negative energy states, so negative energy states exist in quantum mechanics. Whereas in classical physics it is forbidden. There is no negative energy states, negative energy in classical physics. Whereas in quantum physics, negative energy states exist. So correct explanation was given by Dirac during the year 1928 to 1930s. So now we will see this. We have already seen this equation, and we are going to have the explanation of this equation. So E equals plus or minus C squared P squared plus M squared C power 4 to the power 1 by 2. So we have 2 solutions for these energy solutions. We have 2 solutions. One is for positive energy, another one is for negative energy. We know already. Now if suppose if E is greater than 0, for the first condition, if E is greater than 0, this will become E plus. Okay, so you have E plus, and we are going to have only positive energy because energy is positive. We are going to consider. And what are the minimum value in the positive region? That will be your mc squared. This goes from mc squared square to infinity. So on positive side, the minimum value will be your mc square to infinity. Suppose you are going for e less than 0 for the negative solution, and the expression for negative solution will be exactly like this. And whatever the minimum value, it will be minus mc square to minus infinity. So there will be two regions. Okay, so this is exactly explained in the figure. So there will be two regions, as I said, separating 0. Electrons cannot be in the at the 0 level. So very important one. Electrons cannot be at the 0 level. Electron can be only accommodated in the minimum level. So minimum energy will be there. So this minimum energy is always somewhere here. What we call this as Dirac C. This is vacuum level. All the electrons will be occupied only in the vacuum level. So as I said, there will be two regions separating 0. So we have this region, just now we said this is E greater than 0. This region E is less than 0. This goes from minus mc square to infinity. This goes from minus mc square to infinity. See, this is plus mc square to infinity. This is minus mc square to minus infinity. Okay, so Dirac explained negative energy states in a clear way. He says that all the electrons will be occupied only in the vacuum state. Suppose we already studied, suppose we think on the other way around. So we have already studied about Einstein's coefficients. So we learnt in the last unit, we learnt 3 Einstein coefficients. First we will take 2 Einstein coefficients, which is from emission, that is from excited state to ground state. We will consider this. And there are 2 emission rates. One is spontaneous emission, then another one is stimulated emission. For spontaneous emission, can you remember, there will be no external field. No need to have external field. Automatically the electrons will come down. Okay, suppose if at all we think that if at all the electrons are in the excited states, suppose we are going to consider these electrons without any external perturbation, it will come to the ground state. When you are going to come to the ground state, it can occupy any one of the levels, that will violate Pauli's exclusion principle, so which is not possible. The atom will be unstable. So this discrepancy was clearly explained by Dirac, and he says that all the electrons will be occupied only in this level. This is called Dirac C. Dirac C. So all the electrons supporting Pauli's exclusion principle, it has to obey. So now, suppose if there is any external perturbation, external disturbance, say for example gamma ray passes, okay, light photon passes, then immediately the electrons in the vacuum level, they will acquire the energy, and this energy should be greater than 2 mc squared. So this is your mc squared, this is another mc squared. You are going to have the difference. So this will be your 2 mc squared. If the energy of the external field is greater than 2 mc squared, then this electron which is in the vacuum level, it will go into any one of the excited states, any one of the higher states. Okay, so now when it stops, what will happen when the electrons are going from this state to that state? Then immediately a hole will be produced. An empty place will be there. This hole is called a Dirac hole. And Dirac says that this must be an antiparticle of this. This must be antiparticle. Antiparticle we are going to discuss in detail within 5 to 10 minutes. But however, we can say that all the particles will have antiparticles. In the universe, we are going to consider all the particles, whatever may be the matter, everything is made up of only particles, elementary particles. So for every particle, it's like a mirror image. For every particle, there will be an antiparticle. So electron jumps from this vacuum state to any one of the states, in the higher states. Okay, now a hole is produced, Dirac hole, and this hole is nothing but antiparticle of this electron. What we call this as a positron. So due to the external disturbance, a Dirac hole is produced, a positron is produced, and the electron somewhere here in the excited state. So what we call this as pair production. You have a pair. One is electron and another one is antiparticle of the electron, which is nothing but positron. For every particle there will be an antiparticle. Okay. So now after some time what will happen? These electrons, they will recombine with the hole. They will recombine the hole. This is called pair annihilation. When they recombine, it has to emit some radiations. So it will emit some radiations. Okay. So radiation means light energy. So this is the idea behind the negative energy states. So all the negative energy states in which the electrons will be there, that's called vacuum state. So these electrons, when they acquire the energy from outside, from the external perturbation, for example gamma radiation or light interacts with the matter, then these electrons will try to go into the any one of the excited states, okay, and they will have only two greater than, that energy should be greater than 2 mc square, only then it can go, okay. So this is called pair production, and one is called pair production, another one is called pair annihilation. So creation and destruction. So destruction. So one pair is created and the pair is destroyed here by emitting the radiations. So this is idea behind negative energy states. Okay. So this is the illustration of negative energy states and the energy levels of the pre-Dirac hole. So this is the Dirac hole. Okay. So he explained this explanation in the year 1930. He proposed the theory in 1928. For about 2 years he was thinking a lot, and at the end he could explain clearly about the negative energy states. And after 3 years, so after 2 years, 1932, Anderson from US, he discovered this positron while doing experiments in cosmic rays in some chamber. So in the presence of magnetic field, so he could find out the positron. So for the electron there is a positron, this is antiparticle. Okay, he only discovered. So then onwards, slowly, for a proton, for neutron, people started finding out the antiparticles for every particle. So it's a mirror image. So that's why we used to call him Dirac as father of antiparticles. Okay. So from relativistic equation, since sigma is a 2 by 2 matrix, as I said, sigma is 2 by 2 matrix, and E plus E minus occur 2 times where P equal to 0. One is for E plus mc squared positive energy, then E minus mc squared to minus infinity negative energy. The energy spectrum of free particle has 2 branches. So 2 branches corresponding to E plus and E minus. See, this is E plus and this is E minus. So we have 2 branches. One starting at mc squared extending to plus infinity, mc squared to infinity. Okay. Then the other will be starting at minus mc squared to minus infinity. See, minus mc squared to minus infinity. The 2 branches are separated by forbidden gap. This is called forbidden gap, in which no electrons will be there. Electrons will be either here or there. Okay, no electrons will be there in the forbidden gap. Okay, but electron can never be at the 0. This is what I told you earlier. It can be only at the minimum position. The minimum position is somewhere here in the vacuum level. Okay, so this is shown in the figure 8.1. So this is clear explanation of Dirac's interpretation. The vacuum corresponds to all negative energy states being full. So it has to obey Pauli's exclusion principle, preventing electrons falling into negative energy states from here to here. Holes in the negative energy states correspond to positive energy antiparticles with opposite charge. So whenever you are talking about particles, the antiparticles will be opposite charge. Mass will be the same. Suppose if this is minus E electron and this must be plus E electron. For example, if you take proton, the antiparticle will be antiproton. This will have minus sign. Charge will be the same. Charge will be the same. Mass will be the same. Only the charge, the sign of charge alone will change. This is plus E, that is minus E. Okay. The other thing also, the magnetic moment also will change. We'll see later now. So it provides a picture for pair production and annihilation. So this is the clear picture for pair production. This is the explanation given by Dirac, and this is for pair production, and this is for annihilation, pair annihilation. So as I said, so there will be a gamma energy, and it traps an electron. It goes to the higher state, excited state, the electron, creating a Dirac hole. What we call this as a positron. For the electron, it's a positron. See, positron, and the energy should be more than 2 mc squared. It's a very important one. Okay, here it is given as 2 photons. See here, 2 photons. When the electron, see 2 photons here, there will be 2 photons. Only then the electron and positron will be created. And look over here, electron and positron, they will come together, they will recombine and will have 2 photons to satisfy the conservation of momentum, linear momentum, angular momentum, and conservation of charges also. Okay, we'll see later elaborately. So this is for pair production and that is for pair annihilation. So Dirac gave an interesting explanation of negative energy states. He assumes that the negative energy states are usually all occupied by the electrons according to Pauli's exclusion principle. And this sea of negative energy electron has no physically observable effects. A negative energy electron in the negative sea in the vacuum level absorbs a photon of energy h nu greater than 2 mc squared, h nu greater than 2 mc squared, and jump into the state of positive energy state. So negative energy state and positive energy, they are separated by a forbidden gap. As a result, a positive energy electron is created which is observable. Okay, this was discovered by Anderson. So observable, and a hole is formed in the negative C. The hole with energy minus E and the momentum minus P then encoded as a positron of energy. Okay, so plus E momentum and plus P. This is called pair production, and this inverse process is nothing but pair annihilation. So we have a creation, another one is destruction. Okay, it is very difficult to imagine such negative energy states because even a small perturbation would ease a transition from an electron from the positive energy state to negative energy state, releasing enormous amount of energy. So it has to obey E equals mc squared. So mass is converted into energy. Okay, E equal to mc squared. It has to. But no such thing takes place in reality. Hence, Dirac assumed that all negative energy states are occupied by an electron in the vacuum level, and this negative energy electron has no physically observable effects. Further, he suggested that all negative energy states are normally occupied, and the electrons which are ordinarily observed are those in positive energy states. Okay, so these are all outcomes. It is also assumed that the electron occupied negative energy states picks up the energy and goes to the positive state. It is an observable effect that the empty state in the middle of negative energy state behaves as if particle of positive energy, and it responds as electric and magnetic fields. An empty place in the negative energy states is called a Dirac hole, which you have seen, in which positron exists. This is the same character of the positive charge. So it is identical in mass, magnitude of charge with an ordinary electron, but with a positive sign for the charge. Okay, so plus E means that will be minus E. Plus P means that will be minus P. For a proton, this will be antiproton. For a neutron, there will be antineutron, but neutron has no charge. Correct, neutron has no charge, but antineutrons exist. Antineutrons are there. How to find out antineutrons then? How it is possible? Only by means of magnetic moment. So one will be in this direction, another will be in the opposite direction. So only then people will find out. Here it is easier to find out. For a proton, we have antiproton, sign is changed. For an electron, we have positron, again sign is changed. What about for the neutron? Neutron is chargeless particle, correct? There is no charge for the neutron. So people find out by means of magnetic moment. So in NMR studies, people study about nuclear magnetic moment. So in that process, we have magnetic moment will be up, means then another magnetic moment will be down. So one can find out easily. This explanation was accepted in the year 1932 when the positron was discovered by Anderson from US while doing research work in cosmic ray research. Okay, the positron is considered as an unoccupied state of negative energy and the perfect image of negative electron. This is what I said. It's a perfect image. It paves a way to have the concept of existence of particle and antiparticle states in the subject of elementary particle of nature. So they come under elementary particle of nature. Okay. Now we will go for antiparticles. The heading is antiparticles. As I said, lot of antiparticles we have so far we have discussed. Antiparticle for electron, the antiparticle will be positron. For a proton, the antiparticle will be antiproton. For a neutron, the antiparticle will be antineutron. Okay. For everything, the sign of charge changes. For the neutron, as I said, for the neutron there will be no charge. So we have to go only with the magnetic moment. Okay. So Paul Dirac wrote an equation obeyed by an electron having a kind of mirror image. So the mirror image for particle, antiparticle is nothing but a mirror image, and predict the existence of antiparticles in the year 1928. Okay, each particle has an antiparticle, but antiparticles are not found in normal matter, but arise in high energy collision experiments, interaction with cosmic rays and radio decay. So of course we know that antiparticles, for example, we take electron. For electron, the antiparticle will be your positron. Okay. For a proton, the antiparticle will be antiproton. Now we know that to form a hydrogen, we need to have electron and a proton. Correct? For to form a hydrogen, we need to have electron and a proton. Okay. This is what we know for any hydrogen atom. Suppose I am going to combine the antiparticles of these two, that is positron and antiproton, I can form antihydrogen. Is it okay? So this is called antimatter. So antimatters exist, antihydrogen, anti-atom exists. Okay, this is what people think like that. Okay. So now an antiparticle has the same mass, same spin. For proton also plus half. Antiproton also will have plus half. Electron also plus half. Electron will have what of the spin? 1 by 2. Okay. For positron also this will be 1 by 2. Sign of charge alone will change. This is for minus E, that is for plus E. Okay. So same mass, same spin and lifetime as its particle, but it possesses opposite charge, plus E and minus E and plus E. An unstable particle and its antiparticle have the same lifetime. Very important, one more question. Okay. An unstable particle and its antiparticle will have the same lifetime. Some neutral particles and their antiparticles are identical. Example, photon. Other neutral particles and antiparticles are not identical. Okay. The first antiparticle known was positron. So by Anderson, which was discovered by Anderson in the year 1932. It is a positively charged electron. It has the same mass and the same spin as an electron, but opposite charge. So we know this equation very well. When an electron combines with positron, will give us 2 photons. Okay, don't forget this is to satisfy the conservation of momentum and conservation of charges. When an electron and a positron come in contact with each other, we will have this equation. The antiparticle of the proton is called an antiproton. Just now we discussed. It has the same mass as the proton, but an opposite charge and the same spin as proton, but an opposite magnetic moment. So one will be up, then a magnetic moment will be down for the antiparticles. Thus it's a negative proton and it's denoted by P. P 1 bar is there. For P it's a proton. P bar means it's an antiparticle, antiproton. It's harder to detect an antineutron, as I said, because it has no charge. Both neutron and antineutron have 0 charge. Only then they will differentiate with the help of moment. Okay, nuclear magnetic moment. So if a particle meets with the corresponding antiparticle, if a positron meets with an electron, or if an electron meets with a positron, so what will happen? The annihilation will take place. So annihilation means the particle will be destroyed and releasing the energy. One is 2 photons, as I said. This is one gamma, this is another gamma, to satisfy conservation of momentum, conservation of linear momentum, conservation of charges. Suppose if there is only one photon, this will not satisfy conservation of energy. So that's the reason that we need to have 2 photons. All the mass of the particle and antiparticle is converted into energy in the form of photons as gamma rays. Okay, so mass of the electron, you have mass of the positron. So E equals mc square. Exactly, it satisfies. So this is the illustration of annihilation, and this is the illustration of pair production. When any external perturbation, gamma rays, they come in contact with the matter, then immediately you have positron and electron will be separated together. So pair production. The earlier one was pair annihilation. So in a pair production, a photon creates a particle and the corresponding antiparticle, which is nothing but E plus and E minus. Only occurs if one photon has enough energy to produce total rest of the 2 particles. So it has to have enough energy, that is h nu should be greater than that of 2 mc square. So that's a condition. Okay, so we have discussed so far about negative energy states and antiparticles. So antiparticles exist. Okay, so then onwards, lot of antiparticles have been discovered. Okay, so thank you, students. We'll see in the next class. Bye.